Alright, this is section 8.3, and we're going to look at equations quadratic in form. So many types of equations can be written in the form of a quadratic equation. So remember, ax squared plus bx plus c equal to 0 is a quadratic equation, and we've learned 4 methods to solving such an equation. Factoring, square root property, completing the square, and the quadratic formula. So pretty much these equations are going to end up needing one of those methods to finish them completely. So if we look at this first one, I am going to first ask myself, with this polynomial here, is it factorable? So I'm going to see that these three terms share 2x. So I'm going to take out 2x, and I'll get x squared plus 6x minus 15 is equal to 0. That power of 3 also tells me that I should in the end have 3 answers. So this part right here can be equal to 0. I would consider factoring this further, but there's no way to multiply to 15 and add to 6. So I'm going to take this part, and I'm going to also set it equal to 0. This one's simple, divide by 2, x is 0. This one, I'm going to use the quadratic formula. Because it has answers, they're just not found by factoring. So remember, a is 1, b is 6, c is negative 15. So I get x equals the opposite of b, which is negative 6, plus or minus the square root of 6 squared minus 4 times a times c, all over 2 times a, 2 times 1. So now I'm going to clean that up. And I'm going to get negative 6 plus or minus root 96 all over 2. I must always make sure that my radicals are simplified, so what sits inside of here is a 16 and a 6, and I can take the square root of 16. So I get negative 6 plus or minus 4 square roots of 6 all over 2. Now to finish, the numerators share a common factor of 2, which I need to factor out. So I take out a 2, and I get negative 3 plus or minus 2 square roots of 6 all over 2. The 2's drop out, and I'm left with an answer of negative 3 plus or minus 2 square roots of 6. So one of my answers is 0. My other 2 answers are here for a total of 3. The next 2 are going to require us to use a method back from chapter 5. We want to use u substitution. So here's what we're going to do. We're going to look at this first term as x to the 1/3 squared plus 2x to the 1/3 minus 15 equals 0. So what we see repeated that we really don't like is x to the 1/3. So we're going to let u be x to the 1/3. Remember, with u substitution, we're going to take that expression out for a minute and replace with u. So we get u squared plus 2u minus 15 equals 0. Now this factors pretty easily, so we get u plus 5, u minus 3. Now before you continue, you put x to the 1/3 back in. So x to the 1/3 plus 5 times x to the 1/3 minus 3 equals 0. Since it's factored, we set each factor equal to 0. So x to the 1/3 plus 5 is 0, and x to the 1/3 minus 3 is 0. X to the 1/3 now equals negative 5, and the way to cancel out this 1/3 is to cube both sides. So when you take 1/3 times 3, those cancel, so you get x equals negative 125. Kind of looking at this one differently, maybe this would help make it easier. Remember a cube root. A cube root can be represented by 1/3 power, so you could say the cube root of x minus 3 equals 0. So you could say the cube root of x equals 3. And maybe this makes it easier for you to see why we're cubing both sides, because we want to get rid of the radical, and we apply the same power to both sides that matches the index. So a cube root to get rid of, we cube it, and we cube the other side. So we get x is 27.